Okay, let's go and get started today. Hopefully everybody's doing okay so far. Today we're going to get started into, again, this is Game Programming Foundations 1. So far all we have had is kind of a text interface through the console where you type in something, you hit enter, and then the program can do something. And as we saw with that guessing game, you can make games that way. But what we're really after in this class is to get into something with graphics. In other words, something like an arcade game. There's graphics. We're going to press keys. We want things to move around and interact with each other. So that's what we're going to focus on getting started with today. All right, so today, going through the topics, we're going to review a few things. We're going to talk about external modules, which we've already looked at a few of those. And then we're going to dig into what's called the Pygame module and some various things related to that. All right, so let's go ahead and get started. All right, so quick review. Variables, if you remember, they allow the programmer to assign a name to some data object that's stored in memory or some piece of data that's stored in memory. So examples of where we've seen that is like here, I equal 10. And that I equal 10 there, you'll notice that is taking the name I and assigning that name to the value 10. In other words, we're assigning the value 10 to be stored under the name I. We can also have longer names, player score equals 0, player name equal player 1. And those are kind of the variables are a very powerful thing because it lets us take advantage of the computer's memory. And without being able to remember stuff and store things, we couldn't have scores, we couldn't have health, we couldn't have ammo. So that's going to be important for us going forward. And we're also going to use them to store things that are internal to the game as well, like I for a counting loop, like a while loop that repeats something 10 times. So very important. All right, quick review of if statements, decision statements. If some comparison here, if health equals 0, print game over, whatever. So the various forms of the if statement, we saw those. We had the while loop. The while statement works like an if, has a comparison just like an if, indented code just like an if. The only difference is if this is true, it does the indented lines, but then it jumps back up and checks to say, is that still true? If it's still true, it'll do the indented lines again. Jump back up and try again. It'll repeat that as many times as necessary. You can even make infinite loops by saying while true. And if you do make an infinite loop and say something along the lines of while true, then there is a way to get out of it. You can have break, which immediately jumps out of the loop when it encounters that statement, and then continue, which does not jump out of it, jumps back up to the top to check the comparison again. All right, so that's all review stuff. One final review item here is modules. And modules, you'll notice we've used those before. You have to import them. You say import random, import time. That goes out and opens those modules, pulls them into our program. And then after it's been imported, we can use it by saying, for example, here, make the variable d6_roll for a 6-sided die roll simulation, random.randint 1,6. So we're using the randint function inside of the random module that we imported. If we left off the import, this would give an error. So we need to import it to use that. So it's almost like saying go to the library and check out the random book of spells. And then if we have that checked out, turn to the inside of that book, look inside of the Untitled Chapter, and then it has that spell for doing that. Same thing with time. We loaded that, imported that. We use that to do time.sleep. This will pause the program for 10 seconds before continuing on. So the modules random and time, those are standard Python modules, meaning that they come with Python when you install it. And speaking of that, let's just take a quick minute here to look at these kind of different levels of capability. So there's what are called built-ins or built-in functions, and those are designed into Python. In other words, you don't need to import anything to use them. They exist when you run the Python shell, and the examples of that would be a lot of those functions we saw: print, input, the CHR function, the int function, the ord function, the float function. All of those things are built into Python. And there's a whole bunch of those that are built in that we can use without importing anything. And then there's the standard modules that come with Python but aren't built in, meaning that we have to import something, like the functions that are in random, time, math. There are some other ones there as well. The ones that we've used so far are random and time. And then we have installable modules or third-party modules that you can like download or install, but they're still imported just like the standard modules, but we have to download them and install them in order to use them. And that would be an example of Pygame, PyOpenGL, Piglet. There's a whole bunch of other Python modules. And in fact, you can make your own modules as well and then import those. Now these installable ones, that's what Pygame is. So Pygame is a library that was designed for making two-dimensional games. So it includes a whole range of different functions. And those functions range from being able to do things like, notice, obviously 2D graphics, like drawing things, loading images, showing images on the screen, but also has not just graphical capability, the ability to play sound, the ability to play background music or music of some sort, the ability to get input from the keyboard so it can sense when keys are pressed and released, ability to get mouse input, joystick input, camera input. So a lot of things that you would need in order to create a game are included in there. One thing that I should point out, it is a 2D graphics module. You can do 3D graphics with other modules like Piglet, PyOpenGL, for example. There's one called Panda. But keep in mind that we're going to be doing 2D graphics for a while in here, for this semester anyway, to kind of learn a lot of the same concepts, but a little bit simpler workflow. So we're going to be using this module to do stuff. Now the Pygame website, if you're interested, go to www.pygame.org. And it has a whole bunch of documentation and some example code and things like that. But because it's a third-party module, meaning it's not already one of the standard modules and it's not built in, then we have to install it. And after we install it, we can use it. We don't have to install it every time we want to use it. We just have to install it once. And it's going to install it kind of into our Python folders, into the place where Python is stored. So once you've installed it, you're good. You don't have to install it again. All right, now there are two ways to install it, and I'm going to kind of explain both of those here. The first method is using a program that's a command line tool called pip. And what pip is this like Python installer package, or Python package installer program is what pip stands for. Program installer package, Python. I don't remember exactly what the acronym is, but that's what pip does. So it's a tool that's designed to install things for us. Now, that pip tool allows us to install things from a command prompt. And if you don't know how to get a command prompt, basically what you do is go down here in your Windows distribution, type CMD, hit enter. That's a command prompt. So now you can just type in commands here. So for example, I can type pip, and you'll notice it brings up this little help page that tells me things about it. Now, pip is part of Python. Python's distribution comes with that, but you'll notice that pip has command and then options. One of the commands is install. That's the one that we're going to use. You can also uninstall things. And there's some other things as well. We're going to focus on install right now. All right, let me close that back out and switch back to just the presentation. Okay, so the way that you install Pygame is from that command prompt. You basically type pip, and then a space, and then install, and then a space in Pygame. And that's it. You don't even have to go find or download it from the Pygame website. You don't have to do anything. You just say pip, install Pygame, and then pip is kind of has some intelligence built into it. It'll look at your version of Python. It'll go out and look at kind of a standard package list that's maintained. And it'll say, oh, this is the version of Python you have. Here's a version of Pygame that works with that. It'll download that. If Pygame needs other things installed in order to work, it'll find those and install them. But one of the things, if you try this on your command prompt, you don't even have to be in this directory location. You can do that anywhere. But if it doesn't find pip, that means that your system path isn't set up. So you can change into that directory where pip lives, which if you find where Python is installed on your machine, go into the scripts directory, then the pip.exe is right there inside of that directory. So you can find that location, do pip space install space Pygame there, and it will install it. Now, there's another way to do this as well, and I want to just quickly point this out, and that is you can actually use pip from right inside of Python itself. Pip, there's a pip module, and you can actually import that, and then you can tell it to install Pygame there. So in other words, you would click to run the Python command line shell, and I'm going to do this here in just a second and show you. And then once the shell has been loaded, type in the following command. So at the Python shell prompt, type import pip._internal. And then on the next line, might take a couple seconds while it loads all that into memory. And then you say at the next command prompt, you get pip._internal.main, and then parenthesis, open bracket, install, in quotes, comma, Pygame, in quotes. So notice this is the same thing we did back here where we did pip install Pygame. We're just running the pip Python module directly and then saying install Pygame by passing it this list of what we want it to do. This is the command, this is the options, so install Pygame. And then you'll actually see on the screen it go through and download the stuff and perform the installation, and then it will tell you that it's done when it's done. Now, just for fun, let me take a quick look at how we would do that. So let me switch back to the display capture for just a second here. So down here, and you might not be able to see all this because it's a little bit cut off there, but oops, let me go down here. So here, Python, there, notice Python 3.8. I click that to run it, and then I get this that looks, it's not idle. You can install some things from idle, but idle will get slower and slower as the installation procedure. So I would suggest doing it from here. But in here, I can say import pip._internal. Hit enter. It'll take it a couple seconds. Now it's done. And then here, pip._internal.main. And then in here, square bracket, install, and Pygame. And now you'll notice on my machine, I already had it installed. So it told me that it was already installed. It says requirement already satisfied. And then it's done. Also notice I have a slightly outdated version of pip. It tells me I can install that using pip. So I could say pip install upgrade pip, and then it would upgrade itself. I'm not going to do that, but let me show you what happens if you actually do download this. So I'm going to do pip, and then I'm going to do an uninstall of Pygame. Proceed, yes. So now it says successfully uninstalled. And it gave me a permission error because I'm logged in as a different user than who installed it, but let me reinstall it now. And it never uninstalled it because I didn't have the permission. But on your machine, when you install it, it would download everything, and everything would work. So that didn't really, wasn't particularly helpful in showing you how this works because I'm logged in as a different user than when I installed it. But anyway, that should work for you either this way, either that way or that way. Both those work. What I find myself doing a lot when I install these third-party packages is I just do it from inside Python. And that way I don't have to worry about the path being set up right to get to the pip executable. But either way you want to do it, that's fine. One other thing is this is not really an official way that they tell you to do this. So it could be that this change, where they store this main function inside of pip could change in the future. But I know this works on 3.5, 3.6, 3.7, so all the 3.8, all those versions of Python. Actually, before those, when it was back in 3.2, 3.3, you could actually do pip.main directly without this _internal thing. But they rearranged some things. But so I suppose what I'm saying is this will always work. The first method will always work. but you have to make sure that your path is set up or find the location of the pip program. This one, I know will work with the version of Python we're using. Will it work for version 3.9 or 4.0 or 4.5? I don't know in the future what the future holds with that. Okay, so using Pygame. So there are a couple things first here that we have to do. First up, import Pygame, pygame.init. We need to import, just like every other module, like random, like time, we need to import it if we're going to use it. So this should be toward the top of your program somewhere if you're going to use Pygame. Make sure you import it. Now, after you import it, we need to initialize it. And we do that with pygame.init. So that calls the init function that's part of Pygame. And we have to do that before we can do other things with the Pygame module. So in other words, we import it, that loads the code up into memory, and then initializing it kind of goes in and initializes the submodules, the part that does sound, the part that does the graphics, all of those things are kind of included in that. But all we have to worry about is import it, initialize it. Now, after we initialize it, the next thing we want to do is get like a window to pop up, a screen for us to draw things into. So to do that, we use this pygame.display.set_mode. And here, inside of there, notice I have this pair of numbers, 800, 600, in parentheses. It has to be like this. That this is called a tuple, but this is specifying the resolution, or the number of horizontal pixels and the number of vertical pixels. So how wide and how tall is the screen that I'm creating? And I'm just doing an 800 by 600 window. Now, if you wanted to, you could make that larger or smaller, and it's going to bring this up in like a window on the screen that then now we have a display window that's been created. But notice that I have to capture what that function returns in this DS thing here. And what that DS thing there is, that's what's called the display surface. And this is just a variable. You could name it anything. You could call it disp_surf or display_surface, or I just use DS for short because we're going to use it later on. But the display surface is kind of the variable we're going to use, just like we had variables earlier that held the score, and we could access the score through that variable by using that variable name later. This is actually holding the data object that has all of the stuff for the screen inside of it. So we're going to interact with this that screen by using this DS variable that we created. So that's just a variable, and it's kind of referring to the display surface data object that's stored in memory. Just like when we said I = 10, we have the name I associated with the number 10. Here we have the name DS associated with this window that's on the screen. Okay, now that we've created the window, we want to draw some things on it. So we want to make some lines on it. We want to make circles maybe. We're going to look at some of the drawing functions. So the first one is the line function. And notice with the line function, pygame.draw.line. The first parameter that we give to this function, we have to pass in the display surface. So this is the surface I'm drawing the line on. This is going to be the color. This is the red component. That's the green component. That's the blue component. So 255, 255, 255 is making that surface, or making the line that we're going to draw the color white. So that's the brightest white we could get. The next parameter is the x, y coordinates of 0.1. And then the next one after that is the coordinates of 0.2. So in other words, we're specifying the end points of that line, and it's going to draw that line between those 2 points. And the last one is the width. So the width is how many pixels wide is that line. So one quick note about the about Pygame and the way the display surface is set up. The coordinates on that are configured. And yeah, let me switch over to a document camera here for a second and give you a quick explanation of that. So when I create that display surface, let's see, where am I? Right there. I'm going to get this 800 by 600. Here, let's draw this down there. So in other words, so when I say ds = Pygame, oh, you can't see that. Here, let me. All right, I can't fit all that on there. ds = Pygame dot. And as a reminder for how we're doing this, remember that we need to have that display surface before we can do anything else. So pygame.display .set underscore mode. And then we said we want that to be 800, that's a comma, ignore that, 600. So that's making an 800 by 600 window. So this point in the upper left of the screen, we're going to get a window that pops up. I apologize for the bad drawing. I'm kind of at an awkward angle here. That looks really awful. But this point up here, and there is going to be a little title bar across the top. And it's going to have a little icon. It's going to say Pygame. But anyway, this point right there is, I'll move this over just a tad. That is 0, 0. And since it's 800 wide and 600 tall, this lowest corner down here, that is going to be 0.7. I did it again. You can't see that either. I need to move the camera a little farther away. Here, I'll just label it over here. That is 0.799, 599. Okay, I think I fit all that on there. So when I create this display that is 800 by 600, I get one corner that is 0, 0. The other one is 799, 599. If we made this a different size, this is always going to, the last pixel on the screen is always going to be one less than that, because this is the number of pixels, and since 0 counts, it's going to go 0 to 1 less than whatever we put there. So a point right about in the exact middle of the screen is going to be somewhere around halfway across, and we really can't get exactly in the middle, so you could think of this as like 400, 300, or you could think of it as 399, 299. I'll just do 400, 300. That's slightly past the middle of the screen to the right and slightly down. But note that, and we can then, so notice the X increase is going this way, Y increase is going down. And that's backwards from what you're used to in the Cartesian coordinate system, where 0, 0 is down here. So this is actually using what's called screen coordinates, and that's typical of programming, is that it's more like a book, that you think of it like as rows and columns, and the column increases going across, that's our X, and then the other one increases going down. So it's more like a document you're looking at where it increases as you go down, rather than the typical Cartesian coordinate system you had maybe in a geometry class or a trigonometry class. Okay, so let's switch back out of that for a second here. All right. So back to this. That notice, oops, I'm wrong. There we go. Okay. So one final thing before we leave this page, that the colors are always represented by a 3-element tuple with the red value first. And since those, each of those byte values can range 0 to 255, and we know why that is. They're represented by a single byte with 8 bits. And with 8 bits, you can get 256 combinations. Since one of those combinations is 0, 0 to 255. So 0 is lower intensity, 255 is higher intensity. So when I mix as much red and as much green as much blue together, when I mix all that light together, I get white. If I wanted something that was a bright red and pure red, I could do 255, 0, 0. If I wanted something that was more like magenta, I could do 255, 0, 255. If I want something that's like a gray, I might do a dark gray might be like, I don't know, like a 100, 100, 100. Equal mixture, kind of like white, but then dark. And with all of those values there, that gives us the possibility to have 16,777,216 different colors to choose from. So 16 million different colors that you can get out of this. Okay, moving on to circles. The way the circle command works, pygame.draw, and then instead of a line, we do circle. We always have the display surface first, and then we always have the color next. And now circles, though, are different. They don't have 2 points. The way a circle works is we give it the center, and then we give a radius. And then the last parameter is the width. And that last parameter being the width, like that, if you put in a width of 1, you'll get like a single line outline of a circle. But if I put in 0, it'll fill it in with this color. So it'll be a solid circle with that color. And that can be useful. So if you want a solid circle rather than just a ring, then put 0 there. But if you wanted just a ring, you could put 1 or 2, and that's how many pixels wide the ring is. Okay, rectangles. A rectangle, in this case, it's always going to be aligned with the screen. In other words, you can't do one that's kind of tilted or sideways. So as an example, you can do rectangles that are like this, but not at an angle like that. Okay, and the way those work, pygame.draw.rect, and you're probably getting familiar with the pattern. The display surface variable comes first, and then the color. And then after that, now we give this 4 element tuple. 1, 2, 3, 4, and then the width. And again, if the width is 0, it's solid. If it's not, then it'll make a border. And then the parts of this rectangle tuple here are the x, y. That's going to be of the upper left-hand corner, and then the width, and then the height. So in this particular case, we're going to have the upper left corner be at 100, 100. It's going to be then it's going to be 200 pixels wide. So it's going to be at 100, 100, 200 pixels wide, 50 pixels tall. And the height goes down on the screen. So just quickly here, let me switch to this. So in other words, we said that was at 100, 100. So if this is 400, then we can cut that into 4. So there's half. So 100, 100 is going to be like right there. And I'm going to label it 100, 100. And then when we looked at that, we said it was 200 pixels wide. So 100 to 200 to 300. It's going to be right there. And then it's 50 pixels tall. So we're going to get a rectangle that looks like that. So quick question, what is the coordinate of that lower right-hand corner of that? Well, if this was 100, 100, this is kind of, again, I'm at an awkward angle here. It's 100, 100. So if this, if it was 200 wide, then this is going to be 300, because 100 plus 200, remember this is 200 wide, and then it's 50 tall. So then the second coordinate, this is going to be 150. And then since I had a 0 on that, that whole thing would have been filled in white, which I can't really color on a white paper in white, but all right, so let's switch back. Okay, so hopefully that makes sense. One of the common mistakes is to treat this like a line where this is one corner and this is the other corner, but this is the width, that's the height. So keep that in mind. If you're trying to make a shape and it's coming out wrong, keep in mind that this is the width, that's the height. And again, width of 0 makes it solid. Other widths are the size of the border. Okay, ellipses. Ellipses, the function call looks almost exactly like that for a rectangle. The only difference is it draws an ellipse inside of that rectangle. So in other words, if I were to create this ellipse, you can think of this as an imaginary bounding box around that ellipse, and then it'll fill it in so the top and sides just touch that bounding box. So you can do kind of circles that are kind of squished by using this ellipse, and they can be squished like height-wise or this way. You cannot make ellipses that are kind of at an angle like that with this command. There's a way to do it, which we'll see later on. But right now, they have to be aligned just like the rectangles have to be aligned. Okay, a polygon. Now polygons, this here has 3 points. This is allowing us to do a triangle. But you can also do, this is where you can now do things that are at an angle, like a rectangle at an angle. You can do that with polygon, or you could do a star shape. You could do a pentagon. You can do all kinds of different shapes with this polygon function. And the way it works, same as the other one, pygame.draw.polygon, display surface the color you want it to be, and then over here is a list of points. So this is the starting point, and then from there, the next corner or vertex of the polygon is there, and the next one is there. And then once you're done, this will automatically connect the shape back to the original, and then you can fill it in and make it solid if you want, or you put like a 1 or whatever there and have it just be a line. But notice that the polygon can have as many points as you want. So if you want to have shapes that are kind of like a Batman shape or whatever, you can actually just come up with those points, make a list of them all, and it'll connect the dots for you and then fill it in if you told it to. And it will automatically connect the last point back to the first. And a width of 0, again, solid. All right, lines. Now, we already looked at line, pygame.draw.line. This is pygame.draw.lines, and it actually it works a little bit differently than polygon, but very similarly also. Notice that display surface, pygame.draw.lines, display surface, the color you want the lines to be. And then this extra parameter here, you can either put a true or you can put false. If you put false, then it will not connect the last one back to the first. If you put true, it'll connect the last one back to the first automatically. So it'll make a closed shape or an open shape. So in other words, if you put true here, this works the same as a polygon, the pygame.draw.polygon does. If you put false there, it basically just connects the dots from this to this and this to this, and then it stops. It doesn't connect that one back to the beginning. Now, one thing that is different is a width of 0 here. I probably shouldn't have 0 there. And actually, let me fix that real quick because that doesn't make any sense. We won't see anything. Still 1 there. So this width, if you have that's less than 1, you won't see anything because we're saying we want a width of 0 pixels. And it's not a polygon, so we can't fill it in. You can't fill in a bunch of lines because they're just lines. So here, if you have 1, it'll be 1 pixel thick. But if you put 2, then you'll see they'll be a little bit fatter, 3 a little bit fatter, and so forth. And if we have that as true, it'll connect the last one back to the first. If that's false, it will not. Okay, now you can, if you want to, go onto the display and set an individual pixel to a whatever color you want it to be. So just 1 dot on the screen. And the way you do that is a little bit different. Notice we're not using pygame.draw.anything. I kind of wish there was a pygame.draw.setPixel or something like that, but for some reason they did it this way. But in this case, we have to go directly into the display surface and then say display surface, and in that display surface, set the pixel at, we give it the pixel position, the X and the Y, and then the color that we want that pixel to be. So in this case, we're saying the pixel at 200, 300, set it to be white. And as a quick aside, notice you can also get the pixel from the display surface. You can read a pixel off of the display surface and say, what color is that? And that's kind of like if you ever use like Photoshop and they have that little eyedropper tool where you can move it over a thing and say, what color is this thing here? And it'll pull that color into the palette. That's kind of what this does. It says, go to this X and that Y, get whatever color is on the screen at that point, and then load it into, in our case, this variable over here. Okay, a couple final things, and then there is going to be a lab where you're going to do some stuff with this. We're going to do an example in a second as well, and then I'm going to turn you loose on working on that lab. But notice that updating the display, this is a really important topic, and that is when you draw things on the display, they don't show up until you tell it to update the display. And the reason for that, we'll talk about in a second, but essentially, there's a couple ways to update the display. If you can just call pygame.display.update, that says all of the changes I just made, now make them show up on the screen all together at one time. You could also update just a region of the screen if you wanted to, which could, mostly the reason to do that would be for optimization purposes or to make things faster. And the reason being that when I say pygame.display.update has to copy all of that memory that on the off-screen kind of memory buffer onto the one that shows up on the display. And that can take the CPU some time to do that because it has to go through and move them from memory into the processor, from the processor to another place in memory, and it has to do that for every pixel on the screen and for all the color values RGB. And as you might imagine, that's quite a few pixels, as we'll see in a little bit. Now, there's another way to do that as well. Pygame.display.flip does the same thing as Pygame.display.update. So you can use one or the other. I usually use Pygame.display.update, but just note if you're looking at sample code and you see flip, a lot of people would think flip is like flipping it upside down or flipping it that way, but it's not. Pygame.display.flip, you can think of it like a flip book, where it says now flip to the next page of the book, and then or the next cell of the animation. I usually, in our examples, I'll mostly do Pygame.display.update. Now, if you don't do one of these, either Pygame.display.flip or Pygame.display.update, you're not going to see any results of your drawing function calls. So anything that you drew, if you drew 1 circle or 100 circles or 1,000 lines, you're not going to see anything unless you do update the display. Now, why do we have to do that? Why didn't they make it so that, hey, as soon as you draw on the thing, it automatically shows up? And there's a good reason for that. The main reason for that is it gives the programmer control of when the person playing the game sees the display updated. In other words, if you're going to draw a fairly complex scene where you have to like make a rectangle and then you're going to put some lines on top of the rectangle, or you're going to make a circle outline and then put some other circles on it for eyeballs, and you're going to put other things, you don't want to see that drawing and layering as it's happening. You just want to see a face showed up, and then another face showed up, and then another face showed up. You don't want to see it being drawn as it's being drawn. You just want it to do that. The other reason is it can be more efficient because it lets us control when the player of the game sees those changes. We can decide when, and we can decide where, which parts of the screen are updated, which can allow us to optimize that. Okay, now, one final thing, that display mode, that Pygame.display.setMode thing that we used earlier, where we just passed in 800, 600, there are actually some other things we can do with that as well. There's this flags parameter, so I can say flags equal. And then there's some flag options. So for example, if you want to make like a full screen arcade game with this, you can say flags equal Pygame.fullscreen, and then it'll take over the entire display. In other words, when you do that, you won't see windows. It won't be running in a window. There won't be a title bar at the top. There's some other options here as well, like OpenGL. You can make an OpenGL renderable display. You can make a hardware surface as a SW surface for software surface. No frame takes away the title bar at the top. Resizable makes it so that you can grab the edge and then resize it. But when you do that, you have to write some additional code to know when it's been resized. We'll talk about that later on in the class. But for right now, you can just do Pygame.display.setMode and then put the 800 by 600 in the parentheses inside of there, and that's it. You don't need to worry about any of the flags. They're optional. All right. Final thing today is we had a command set mode that loaded the window and made it show up. We now want one that destroys it, gets rid of it, and makes it close. And that is Pygame.display.quit. That closes the display surface window. And your program should always close that window before terminating or before ending. Otherwise, you'll be left with a window on there and the program will be done. You can still get rid of that window by like killing the program or killing Python, but it's more convenient and better practice to just, you open the window, you close it. There are a whole lot of other features and functions as well. We're going to look at more of them later on in the coming weeks. We're going to look at how to do input. We're going to look at how to get keyboard key presses. We're going to look at how to do sounds. We're going to get through a whole lot of that stuff. But we'll stop there. If you are interested and want to play with it, feel free to go to pygame.org. There's a documentation section that has everything that you could ever imagine there. But before we're done for the day, let's do a quick example and see this thing actually in action. So I'm going to first off say we're going to draw a face in the middle of the screen. So I'm going to switch back to the document camera for just a second here. So I'm going to, here, let me make a new one of these. I'll just flip. I'll just flip that over. All right, so let's say, again, here's the screen. and we want to draw a simple face in the middle of that. So again, there's the center. So what I'm going to do is I'm going to make my face kind of like just a circle. So we want a circle that's about there. So that's our starting point, is we want to make that circle, and that's a really bad circle I just drew there. But you get the idea. And then we're going to make eyeballs. And then I'm just going to make a line for a mouth, like that. All right, so now you might think, all right, so we're going to have, and I guess let's make a little circle for the nose too. So you might say, how many things are we doing to draw? 1 for the head, 2 for the left eye, I guess it's right eye, 3 for the other eye, 4 for the nose, 5 for the line. So we're going to have 4 commands that we need to actually do that. Now, let's take a look at where those things are. So the head, let's start with that. 1, head. All right, so that is the center of that is going to be at, well, let's do 400, 300 because it said in the center of the screen. And what radius do we think that should be? Well, let's make that about 100. And this is a circle. Now, what about that eye? That's another circle. So so it's going to be 2. I'm going to call it left, so it's going to be screen left, not its left. It's not even a real thing, so left eye. That's going to be a circle. And that one's going to be, now that's not at 400, 300 anymore. It's to the left of that and up from that. So we need to subtract from the x and subtract from the y. Now, how far over do you think that is? Well, this is a radius of 100. So maybe that's about halfway across there. So that would be about 50 over. So the center of this one is going to be at 400 minus 50. So in other words, 50 over. And we'll just say 50 up. So this is going to be at. So 50 less than that is 350. 50 less than that is 250. And now the radius is much smaller than 100 now. Let's just make the radius like 5. Now 3 is the right eye. That's also a circle. And that, though, is 50 over and 50 up. So now 50 over is going to be 50 more than the 400 up here. So 50 over here is going to be 450. And this is still going to be up, so that's still negative or subtracting, so that's 250. And then we'll keep the eyes the same size, so that one's going to be 5. Now, 4 is going to be the nose. And the nose is going to be a circle. The nose circle is going to be at the same center of that, so it's still 400, 300. And the radius of that, oh, let's make it the same as the eyes, so 5. And then finally, the last thing is going to be the mouth, which is going to be a line. And the line here, remember the way line works is we pass it 2 points. And then a width. I'll keep the width at 1. But the 2 points for this line, notice that's 50 to the left. So again, that would be 350. But now 50 down, so that's 50 more than 300, so 350. And now we want that to go that way. So now this is going to be 50 this way in x, and that was 400, so 450. And the y is the same, so 350. All right, so now we know what it is we're going to build, and it can be helpful to kind of draw this thing out like this ahead of time and think about where it is you're going to put the stuff. You could even use graph paper if you wanted to, or you could use like you could go into like something like Photoshop, or if you don't have Photoshop, there's a program called paint.net that's free that you can download. It's kind of an open source thing, kind of like Photoshop, that lets you do that. And you can move the cursor around and look at what pixels you're at and even kind of sketch out what you want in there to help figure it out. But let's go ahead and now write this actually in Python. So I'm going to go switch to a display. And let me go ahead and run idle. And let me move this so you can see it. All right, now I'm going to not do it from here. I'm going to go ahead and make a new programming window, new file. Make that so you can see it. Right about there. All right, so first thing, I'm going to put a comment. This is going to be like Pygame test. All right, so first thing, if I'm going to use Pygame, I need to import it. So I've imported it. Now, before I do anything else, if you remember, we have to initialize it. Now that Pygame is initialized, we need a display surface. So ds equal pygame.display.set mode. And we did 800, 600. Now we have the display surface. Now we're ready to do something with the display surface. So the first thing we want, here, I'm going to put a comment here. This is going to be the head. I'm going to do Pygame. And if you remember, what we want to do here is we want to go ahead and draw these things. And the first one, let me look back at the paper, what we put on there. The first one that we want on here is the 400, 300 as the center, and 100 as the radius. So Pygame dot draw dot circle. And then for the circle, display surface. And then this is the color. The screen is going to be black, so we'll just leave this white. 255, 255, 255. And the next thing is the center, which we said was 400, 300, and a radius of 100. Oops. And then a width, I'm going to make the width 1, so it's just going to be a ring. Now, one thing that I would do is let's go ahead and see that we get that circle. Well, let's go and just run it right now. And it's going to need a name. Pygame test1.py. And we don't have Pygame installed because I messed it up earlier. And I said this was a bad idea to do this from inside of here, but we're going to try it and see what happens. And this is what would happen if you ran it from the thing anyway. Notice it says successfully installed Pygame. Now, if it hadn't already been downloaded, then you'd see it download it. You'd see a little progress bar fill up, and then it would install. But at the end, notice it'll say successfully installed. All right, so that actually seemed to work. So let's go back now and try to run our program. So we didn't have Pygame because I uninstalled it. Apparently it did uninstall earlier when we thought it didn't. So let's go and run this again. And notice I get a window. Notice it says Pygame window up there, but nothing showed up. Where's our circle? Why didn't we get a circle? And now notice also, I can't close it. And the reason is because the program actually ended, but we never closed that window. So a couple things. The first thing is no circle ever showed up. That's because we never did an update. So pygame.display.update. We need to do that. Now let's run it again and see what happens. So now we have our circle in the center of the screen, radius of 100, but it doesn't ever close, and that's because we never closed the window. So let's add the code to do that. So I can't close that. So let's add the code to close the window. And again, pygame.display.quit closes the window. And so now when I run it, the window pops up, you see a circle, it immediately closes. Now, we don't want that either. So I'm going to actually leave that up there for like 5 seconds. So to do that, import time. And down here, before I do the quit, I'm going to do time.sleep for 5 seconds. So now when we run it, it should show the window. 1, 2, 3, 4, 5, and boom, close. Okay, so we have the head. Now let's draw the other parts of this, and let me kind of collapse that a little bit. So that was the head. The next thing we want is the right eye, or no, left eye we did next. And looking at our notes we had from earlier, pygame.draw.circle on the display surface, color of, let's make the eyes a different color. Let's make them blue, 0, 0, 255. And in this case, the center of that we said 350, 250. So 350, 250. And we set a radius of 5. And we want it filled in, so I'm going to put 0 there. Now, before I do anything else, let's take a look. All right, so it's maybe a little bit too far to the left, maybe it's a little bit too far up, but that's okay. It's also kind of small. Let's just make it a little bit bigger. It's going to look dumb, but I'm going to make it bigger. Let's make it a radius of 10. Take a look at that. All right, that looks a little bit better. Still looks a little derpy position-wise, but we're going to go with it because that's what we had on our paper. So now let's do the right eye. So we had left eye. Lopez. TLC joke for you. You guys probably don't know what I'm talking about. And if you go looking for that, that's probably like chasing waterfalls. Maybe you should stick to the rivers and the lakes that you're used to. All right, anyway. Now let's do the right eye. So the right eye, when we did this before, we said 450, 250 instead of 350, 250. So we just changed that to a 4. And notice I copied and pasted that rather than retype all of it. Let's look at that. Now we've got the left eye and the right eye. Now all we need is the nose and the mouth. And 5 seconds, that closes. So the nose, that was a circle too. So I'm just going to copy this, put nose. And the nose was at the same place as the head, which was, let's make the nose red. Let's make it a little bit brighter than that. Let's make it a little bit more toward the pink side. All right, so this was should be at 400, 300. Again, the same center as the face. We'll keep it the same size as the other ones, and we'll keep it filled in. Let's look at that. Okay, not too bad. It doesn't look great, but it'll work. All right, last thing we have is the mouth. Pygame.draw.line on the display surface. And now notice that Pygame has been imported, and we've run this once. It brings up this nice tooltip so we can see things here. So we have the surface that we're drawing the line on. The next thing is the color, which in our case is going to be 255, 250. We'll just make this white. And notice that the tooltip went away. If you want it to come back, you can come back here and put that parenthesis again. It'll bring it back for you. It'll actually go away when you open a new parenthesis because it's kind of, whoever wrote this idle thing is kind of, it's written in kind of a naive way where it says, oh, they open another parenthesis, so they don't care about this thing anymore. And it closes it. It'll also close it when you close the parenthesis. All right, start position. Well, we said the start position for that was going to be, again, I opened a parenthesis, so it closed it, was going to be 350, 350, 350, 350. And the end coordinate was 450, 350. And we made the width of 1. And let's run that. And there's our mouth. 1, 2, 3, 4, 5, close. And now we have a program that draws a face on the screen. Now, one of the cool things about programming is if I don't like how that face is, and I say, you know, I want to have a bigger nose. I don't think the nose looks good. And I can come in here and say, well, let's try this with like, I don't know, like 15 radius instead. That looks a little better. And if we wanted to, we could give it eyebrows. I could give it like pupils by drawing more circles. I could give it like a white of the eye, like a sclera, and then an iris, and then a pupil by having 3 circles. If you wanted, you could add little red lines inside of there to make it look a little bloodshot. You could do all kinds of stuff with that if you wanted to. And if I wanted, I could even draw another line for the nose to make it so the nose, rather than just like a circle like that, has kind of a line and a circle. Or I could even have something like a polygon, a triangle for the circle, or some more complex shape. But notice that that it took a really small amount of code. Make sure it all fits on one page here. Let me move this so you can see all of the code at once. So there's all the code on one page that draws that that little face. And you could be as complex as you want with that. Now, the lab, you're going to be drawing some things too. So what I would suggest you do, here, let's just switch back to the slides. And let me close that. All right, so we drew the face. So that's all for today. I went ahead and posted the lab, so you might want to go and get started on that today. But I'm going to kind of go over the lab a little more carefully next class as well, and you're going to have some lab time to work on that next time as well. So make sure to take a look at that lab sheet, make sure to get started, and other than that, stay safe. Feel free to play around with that. One final thing, if you forget how any of that works, you can always obviously go back to the slides here, but remember that you can always go to pygame.org and let me pull that over here. And notice on pygame.org's webpage here, there's a thing here that says Docs. If you click on that, it takes you to the documentation section. Now, this might be a little bit confusing when you look at that, but notice that we were using like draw. So if you click on up here where it says draw, it'll show you all of the different functions that are inside there. So there's rectangle, which we saw earlier, polygon, which we saw earlier, circle, ellipse. We didn't talk about arc, but it has an arc, line, lines, AA line, AA lines. We didn't talk about either of those. That's an anti-alias line, which is a line that looks a little smoother, a little crisper. So you don't have little jaggies on it that you'll see on the screen. But it also is a little bit slower. So you can look at any of these. So if I want details about how the circle works and I forgot that, I can just click on that. It'll say pygame.draw.circle and has all of the stuff that you can do with that, including sometimes if you scroll down, they have this thing that says search for examples. You can click on that and then it'll show you some examples of it being used. But all of the documentation, you'll notice that in Pygame here, there's a bunch of stuff here with fonts that we're going to be dealing with later, the keyboard. There's this mixer that mixes sounds together, mouse to get mouse interaction, time, it has its own time modules inside of there, music for playing background music, joystick, cursors, so you can change the cursor from an arrow like you see now to other things, transform, which lets you load pictures and stretch them or rotate them and do things like that. Free type, which is another kind of font, MIDI, which lets you actually play like musical instrument, digital interface songs out of it, that would go to something like a software synthesizer maybe or something like that. More sound stuff, some math stuff, camera, CD-ROM, and there's some touch stuff in here too that you can do for if you have like a touch screen, so you could actually interact with those events. So a lot of cool stuff in here, very powerful, but it is entirely two-dimensional in nature. All right, so let's go ahead and stop there. That's all for today. So stay safe, wash your hands, and take a look at that next lab. You're going to be drawing some things on the screen. Make sure when you look at that lab and it asks you to draw things, observe the sizes. So, for example, it's going to have you draw like a little Pac-Man ghost, and it's going to tell you how tall it needs to be. Make sure you're not making it bigger than that. Same thing with the Pac-Man. Just make sure to, and some of the things you're going to have to think about, how am I going to draw that? And one of the things in Pygame, again, when you look at the code, is it draws them in the order that you specified. So, for example, if you wanted to do the eyes with a sclera, a white, and then an iris, and then a pupil, you'd have to draw them in the right order. Because if you did them in the wrong order, the white would cover up the pupil and the iris. So you think about how you would do that onto like a canvas or a piece of paper if you were to lay those things up. So the order can matter when you draw things. So keep that in mind. And when it asks you to do the Pac-Man, and it has the open mouth that's black, you're going to have to probably do a yellow circle and then a polygon in black that covers up the part of the circle to draw the mouth. All right, so that's it for today. Wash your hands, stay safe, and that's it for today.